Hello everyone, this is going to be the last lecture on magnetism. So today I want to talk about some applications about induction. So last time we mentioned that by changing the magnetic field, we can induce the current. So how do we use that? Like in what kind of application that you will see in your in life? So today I'm gonna go over a few applications. There's a lot more, but I just pick three, which I think are the most interesting. The first one we call emotional EMF. So emotional EMF is something that you will see a lot, but you don't know that you're looking at it. So for example, emotional EMF is saying if you have a rod, a metallic rod, and if it's moving in the magnetic field, then there will be a charge separation, or like there will be a very like a momentary current going through this rod. So for example, when you're on an airplane, when the airplane is flying across the earth, and the earth has magnetic field. So when the airplane, like the wing is made of metals. So when that wing cut across all the magnetic field line, it will also induce the current, like induce the voltage across the wingspans. So a lot of examples can be seen like that. So to explain the physics behind that, I'm gonna start from something that we know already. So think about this case where, say, I have a conducting track. Here, this is a conducting track, which means it's rails, which is fixed. And now, if I just put a rod on top of it, but which can slide. Okay, so so what happens if we move the rod, slide the rod to the right? So if we slide the rod to the right, you can see if we look at this loop, if you slide the rod to the right, you will get more magnetic field into the page. So this loop will be unhappy. It's like, oh, why would I have so much extra? So this rod will try to create a current such that the current will induce the magnetic field going out of the page to counter that. So which means you will feel the current going counterclockwise. Okay. So eventually, if you move this to the rod to the right, you will generate the current counterclockwise. So now what if, okay, so now what if we take out the rails? Okay, okay, so here this is a derivation. Okay, so sorry, let me continue on this one. So we just talk about the direction, and we know what's gonna happen. So let's really grind in details about the quantitation. So let's see, this guy will generate a current coming this way, right? So if it generates a current coming this way, we know the current will only move forward when you have a potential difference. So now here you see a current, which means you will have a voltage difference. So which is EMF. Okay. Because the voltage is generated by this magnetism, the change in flux. So it will generate a potential difference. We call this generated potential difference EMF. This generated EMF is nothing but a change in the flux. So because we want to counter the change in flux, and then we know the flux is B times A. A is the area, B is the magnetic field. And here B is the constant, but the area of this loop will change. And because the area of this loop will change, we can look at that area, which is this one. This is the area. So this area is nothing but the length of the rod times the delta X. Okay, so we can sub that in. Okay, so delta A is nothing L times delta X, where L is a constant, and delta X over delta t is the speed. So the voltage generated by moving this rod, that voltage will be BLV. And if I want to find out what is the current going on this track, say if this rail is attached to a resistor, okay, then we can take this voltage divided by the resistance, then we will get the current. So the current running on this rail will be BLV over R. So, so this is what happened. This is basically a case that we already know. But what if now we remove this entire rail, right? We remove this entire thing. So say, remove it. I remove it, so it's all done, it's all gone. And I only have one rod left. Then so my question is like, will I still create a current if there's no loop? Okay. If I don't have any loop, then the change in magnetic flux, which doesn't make sense anymore, right? Because we don't have an area to catch that magnetic flux. But do I still have like a voltage? Do I still have that EMF, the voltage difference across this rod? And the answer is yes. So let's look at this in more detail. Even though there's no loop, but we can try to think about what's happening, what is happening to the charges inside this rod. So this rod, if I look at it carefully, this rod has a lot of iron atoms. So iron atoms, which means it has some protons, it has some electrons, some protons, some electrons everywhere. Okay. If I'm moving this rod to the right, which means I'm moving all these protons and all the electrons to the right. So say if I'm trying to move the proton to the right, and in this magnetic field auto page. So if we use your right hand rule, you can see V to the right. So for you, V to the right, and the field is out of page. Okay, so you can see the thumb is going downward, right? And which means all the proton will feel a force which is going downward. Okay, so now you can see that all the proton that will they will be pushed downward. Okay, and the same idea. If I am trying to move an electron to the right, then because it's a negative charge, so the magnetic force will be upward. So you can see all the negative force, all the negative charges are accumulated at the top. So here you can see a separation of the charges. So since there's a separation of charges, so when you started to move this rod, you will see a momentary, if this is time, this is current, you will see like, shoo, there's a current coming in. There's a current flowing in this direction. But soon enough, once the charges separated and they just happily stay there, then there's no current moving across it. So indeed, there will be a momentary current when you start to move it. But then soon enough, that current will died out, and just because it's all separated. So in the very, very beginning moment, you will still get a current which is the same as above, which is the same as the answer that you derived for this. Okay, so it happens to be the same. So usually this is what people will say, like if you can take a conducting rod to cut through, like a knife, like cut through the field lines, then you can also create a voltage difference in EMF across this rod.